Hello everyone, in this video I will show you how to create a zero-knowledge proof of SHA256 hashing algorithm using Risc Zero zkVM. So just like in the previous video, I showed you how to create an example project using Risc Zero zkVM. In that video we had a very simple example with multiply function where we had like two secret inputs of two different numbers, but this time we will have something more practical. So before, if you are not familiar with hashing algorithms, like for example SHA256, it is a one-way hashing algorithm. You can put almost anything there. So for example, let's say I would just input ABC, and as you can see, it gives this kind of output. So it is just a sequence of some kind of characters, numbers and letters. As you can see, you cannot understand probably anything from it. And like I said, you can just hash it one way. So in this case, it is, for example, how passwords work. So for example, when you log somewhere, you just give your username and password, then you send it to the backend, and on the backend, it's hashed and compared with the database record. And it's done for the several reasons like that. So we firstly have to send the password itself. However, there's always some kind of, let's say, degree of danger that your password can get stolen, especially if the connection is not secured. So in this case, we could, in theory, create a zero-knowledge proof mechanism which would allow us to, let's say, send only the zero-knowledge proof of the password instead of sending the password itself. So let's say the output can be even public in a way, but we don't know what is the input, so only you as the owner of the, let's say, the password or secret can know what is the input. And in this case, you could just create a zero-knowledge proof that you know the input, how to create this kind of output, or let's say whatever the secret is. So let's have a look. How can we create such a project using Risc Zero zkVM? First of all, you have to create a new project. For example, cargo Risc Zero new, and name of the project. In my case, it's SHA256. Once you have this project, you will just have this boilerplate code here. So first thing we can start from is just this hashing algorithm inside of the guest code. So as you can see, we have this method name here. What we can do here is implement the hashing function inside of this code snippet. So first of all, we can just add this here and add some kind of data. It can, in this case, it will be string, so you'll read it from the environment. And also we will want to add the expire date, because still, if someone gets your, let's say, proof, they would reuse it unlimited number of times. So we have to add some kind of expire mechanism. In this case, we can just pass the, let's say, some date, and just agree on some kind of expire date. So for example, if the proof is older than few minutes, few hours, days, whatever, it will be invalid. So in this case, it is another, let's say, layer of security. So let's create a date now, and it will be type of unsigned integer 64. We will pass it from the outside, from our prover host. And at this point, we can create the hash itself. So let's create something like that. And we will need some external libraries. For this purpose, we have to import them here. As you can see, we will need environment once again. So use Risc Zero zkVM guest env, and also use Risc Zero zkVM SHA, and we will need impl and SHA256 methods. With this, we can implement it and hash bytes. Now we can pass the reference to our data as bytes, and that should be all. With this function, we can hash strings to SHA256 hash, and at this point, we could just commit it back to our environment. And here we can of course pass the reference. Actually, we should just dereference the SHA hash, as it's a type of digest. So it should look like that. but in this case we will have only the hash itself. So what about the date? That's why we should also create some kind of, let's say, a struct that will be returned. Instead of just one value, we will return a struct that will contain both the hash and the date. For that reason, we'll create a new folder here. But before we start doing this, we also have to add one more thing to our cargo toml inside of this guest code, as we are using a standard library for string, as you can see, and it belongs to Rust standard library. As you can see, it's experimental, so we have to remove it from here and go back to this file and just add this features standard after a comma. Can just do something like that. Also, we can actually change this method name, but it's not that important for now. So inside of this main folder, we can create a new folder, let's say, in this root folder called core. And inside of the core, we will have some kind of, let's say, helper functions, let's call them. First of all, we will create a new file, cargo.toml, and let's give it some attributes here. So name, let it be jcore maybe, version. Okay, so the overall cargo toml file should look like this. And now we can create another folder inside of it, which will be called src. And inside of the src file, we can add the struct with actually file called lib.rs with the struct that we want to do. So in this case, it can be public struct called, let's say, date and hash. It will be type of digest, and public date type of unsigned integer 64. That's not all actually. We will have to add some macros here with derive. You can just print it out. Deserialize equal to compare partial equal and serialize. Now we also have to import those libraries here. So we can use core fnt format for debug and Risc Zero SHA digest, as well as serday for serialization. So it will be deserialize and serialize. And once we have this core struct implemented here, we have to add this to the workplaces inside of the cargo toml. So we also have to add it here as core. That should be enough. With this, we can go back to our methods file and just implement the missing struct. So we can just implement it like use sha. We also have to implement this core, of course, here in the dependencies under the guest src cargo toml file. So sha core to folders up, and that's all. So now inside of this file, we can just define a new struct type of sha, date and hash, like that. So it can be new sha receipt, will be date and hash. Hash will be dereference sha hash, and date will be date now. And now instead of passing the hash, we can just pass the struct itself, and that's all. This is how our guest code should look like. Now we can add the host logic. So under this main file, what can we do here is, normally actually we could change those methods names. Let's change it to sha. Inside of here, we can also change it to sha. And here in this main file, now we can just find this method name. We can rename it to sha. So now we have the prover and the verificator here. So what can we do now here is just create a new string that we will hash. So for example, string to hash, and let's call it ABC, just like in the example, to string. And here below the prover, we can just pass it as an one of the arguments. So prover dot add input, and just like in other projects, we have to use this method toVector to convert it to vector. We also have to add some error handling. So expect should be serializable, and that's all. So we have the first argument passed, but as you may remember, we also need to actually import this method first of all. So what can we do actually is do something like that. Need from slice as well as to vector. From slice will be for the result. And now we will also need the date. So how can we get the date of the execution, let's say, of the creation of the proof? So we can use the standard library system time. So let's create a new variable called time now, and we use the system time. As you can see, it was imported automatically, and inside of the system time now we have the method like now, so we can execute it. However, it will return us some kind of object, and we will want to get just some values. Actually, in this case, we would just want to the Unix seconds that passed from 1970. So let's change to duration since, and we will use some kind of const here, system time, and it's Unix epoch, as you can see. So since this 1970, and since it returns us the result, we will have to unwrap it as well. And below it, we can create another variable called Unix seconds and time now. And from this, we will just convert it to a seconds. And that's all. With this, we can just copy this line on 17, let's say. And instead of passing this string to hash, we will of course pass this Unix to seconds. And that's all for the prover creation, let's say. Now we will also want to get the, let's say, the result. Let's check the result here. So let's make the new result variable, and it will be type of date and hash. We will have to import it as well. So we have to copy it from here actually and add to host cargo toml file. This time it will be a bit closer. And now we can just import it like that. So use SHA core and date and hash, and that should work. So now we have this object as a result. And now what can we do is just read it from the receipt itself. So from slice, we will pass the reference to receipt journal, and of course some error handling. Error for now, but we can just customize this message. To just prove it, we can print it out, print line, and here we can just add message. I provably know data whose SHA256 hash is, and here we can pass the hash and time. We can add the information for the user, Unix seconds, and here will be the second variable. So of course it will be result dot hash, and second one will be result dot date. With this, we should be all ready to. Now we can just remove this. We don't need it. We can just run our code and see does it work with cargo run release. And as you can see, it looks like our code works. We have this hash. It was ABC, as you can see here we can just compare, and the hashes are the same, so it looks like our hashing algorithm works correctly. And also we have the time expressed in Unix seconds. Here at this point, if you wanted, we could just create the serialization of the files, so we could just serialize the receipt itself. And actually we should also serialize the image ID as some kind of temporary workaround, as currently there is some issue with Rust compiler and with deterministic, let's say, image ID creation. So normally as a verifier, you should be able to verify the given receipt just with the serialized, let's say, receipt and the source code, so you can create the image ID yourself. However, currently it's in most cases it doesn't work, so you'd have to also serialize the image ID. However, it's not the topic for this video, so I'll just skip it for now, but if you want, feel free to check out our previous video where we showed how this process looks like. Maybe we'll also create just a video for the serialization of image ID and the serialization as well. And as a last point, actually, this whole project works. We have the whole workflow now. If you want, we can just create a test here to verify does it work. So we can just define test like that using this macro cfg this test, and below this we can just define new module tests, and inside of tests we will need actually the same libraries as here, so we can just copy paste. We can actually copy this whole file as well and just modify some things, because most of this this logic will be the same. And here we can define our test. For example, we have one test defined with this macro hashtag test, and here we can just define new function. So let's say proof SHA, this will be our test, and here inside of this we can just pass all of this that logic that we had above. So the prover looks the same, time also the same. String, I would just pass it from the outside, but we could also leave it actually here. The receipt is the same as well. Actually, in this case, yeah, so we can also leave the result. We probably don't need the printing out, so we can just remove this from here. Verification can also stay actually. And here additionally we can just add this assert equal. So what we would check, for example, the result hash, and we would hash ourselves also something on the outside, let's say, and check did it work correctly, for example. So just like we had this function inside of the guest code, we can just copy it and define something here. Let's create a new const here. Let's say test str, and this will be type str, because we can just define outside of the function just primitives. So it will be, let's say, this bus maybe. And here what we could do, we can just rename it to test hash and pass test str to string, and with this we can just compare those two. We have to also dereference it, test hash, and here we expect zkVM output to be the product of the inputs, let's say, or let's change it. We expect the SHA to be the same as above, for example. Okay, this time we don't have any error, so we are just using the same constant string here. We are just converting to string, and we also needed to import both the implemented SHA256 libraries, and now we can just execute cargo test command. And as we can see, tests are passing as well. So it looks like everything works correctly. And this is the whole workflow for implementing the prover verifier zero knowledge proof for SHA256 with the expire date, as well with some kind of basic tests here. So thank you for your attention, and if you have some kind of comments, feedback, please leave them below, and we hope to see you again on our channel.